in this example, we're going to take a look at how we would solve a systems of equations. Now, we're going to learn in lessons after this that there are multiple ways to solve a system of equations. The first and most popular way that you would know how to do this is through the graphing method. Since you've learned how to graph a line, you can simply graph two lines on the same graph and look for the common solution. So that common solution, or that common ordered pair that makes both statements true, will be the point where both graphs cross each other. So in this particular section, we're just going to focus on solving these systems of equations by finding the point of intersection between two graphs. Now, a couple situations that you'll have to deal with. If you look at example number 2, we've given you two equations. Both of them are in standard form. So you've got a choice here as to what you can do. You can either take that and convert it to slope-intercept form for both parts, and then graph both of them in slope-intercept form, or you can do the intercept method. So if you want to graph both of the intercepts, so you could say graph both of these points and end up graphing both of the lines that way. It's your choice, whichever way you feel is going to be easiest for you to graph the two lines. Now, what we're ultimately looking for here is this, that we get both lines graphed, and we're looking to identify that point where they intersect. And so you can see here in the solution we've graphed both lines, and we've got this point 2, 1 is the point of intersection. And so 2, 1 is actually the ordered pair that makes both of the statements true, or both of the equations true. So since it's true for both of them, you know that it is the solution to the system of equations. Now, we do have one drawback with solving systems graphically, in that since it's in a visual format, if you're not very particular about where you plot your points and drawing your line with a straight edge, and you don't get a good clean intersection, you may not be able to tell the exact point if it's not going exactly through a grid line. And so you're going to need to pay particularly a close attention to the way you go about graphing these things. So let's go ahead and take a look at sample problem number 2. You have a system of equations here, and you have one choice. You have a couple choices here. You can either graph them using the intercept methods, or you can graph them by converting them to slope-intercept form. So go ahead and choose your method of graphing both the lines. Remember, graph both lines completely on this graph, and go ahead and pause the video now and do that for me. Since everything's even, I'm going to choose to actually just go ahead and convert this to slope-intercept form. I think that would be an easier method. Okay, I've converted both of these to slope-intercept form now, and I'm just going to simply graph both of these lines on the same graph. Now keep in mind, this is different than a piecewise function. On a piecewise function, we were graphing two parts of a line, but we had a range of values that we didn't want to use. That's not what we're doing here. We want to graph the entire line for both lines across the entire graph. And make sure you're not using a little bitty short line. Sometimes if you do that, you won't see the point of intersection. We want to graph them fully and wholly all the way across the whole graph. So I'm going to go ahead and graph that right now. Y equals x plus 4. Start at plus 4. Up 1 over 1. Up 1 over 1. Okay, and so you can see here I've graphed the equation y equals x plus 4. Okay, now I'm going to graph the second one, y equals negative x plus 2. Start at plus 2 from a y-intercept, and I'm going to go down 1, back 1, down 1, back 1, and now I'm going to graph this line. And now you can see that I've graphed the line y equals negative x plus 2. Okay, and so what we're looking for here is we have both of these lines graphed on the same coordinate plane, and we're looking for that point of intersection where they're going to cross. And so we can kind of see here, if we go back 1 and up 3, we can kind of see that that's their point of intersection. And so in this particular case, negative 1, 3 would be the solution to the system of equations. Now, if you had not taken your time and drawn a nice line with a straight edge and gotten a good clean line on both of those, you may have not seen it cross exactly at that grid point, which could cause a problem. So be sure to take special care with your lines. Now, there is a way to check this on your calculator, so I'm just going to transfer over here to the calculator. And you can see that I've already graphed both of these lines on the calculator. So if you haven't done that yet, go ahead and pause the video and graph both of these lines on your calculator. Now, what you're going to find is maybe you can't tell that that's back 1 and up 3, and you're unsure of where that point of intersection is. I want to show you something on your calculator that'll help you find that. So if we go here, I'm going to go to Menu, and then number 6 is Analyze Graph. If I hit number 6, there's a button. You may not have all the ones that I have, but you can see one that says Intersection. So go ahead and hit the intersection, and it's asking for a lower bound, and you see this kind of this hand. It wants you to place this on the left side of that point of intersection, and then just click the middle of your mouse pad or your touchpad. Now it wants the upper bound, so I'm going to drag this to the right, and then I'm going to click it again. And you can see what it's done here is it's created the intersection of those two lines. So that's one way that I can get the calculator to help me verify the solution to this systems of equations. Okay, so that is solving a systems of equations through graphing.